Okay, our last week of these videos, we're going to talk about angle relationships. A lot of background knowledge is going to come into play, a lot of review. We're going to build on some of it, but it all stems from this information right here, being able to classify angles. Okay, so let's take a look. We have angles that are larger than 90 degrees and they're obtuse. And we have angles that are smaller than 90 degrees and they are acute. Okay, notice we have a box in this angle. That means it's a right angle. It's exactly 90 degrees. And the semicircle is 180 degrees, so this one is likely named a straight angle. Okay, and so we are going to build on this knowledge right here. Basically, every concept stems from this. Okay, so good base knowledge is important. Another thing that's important is to remember that the three angles in a triangle, or the interior angles of a triangle, always add up to 180 degrees. They'll give you measurements here, such as this 45 on both of these. That's the measurement of just that particular angle. This one could have a box on it. If you add all of those together, we'll get 180 degrees in each of these triangles. So very, very important. Interior angles of a triangle are going to add up to 180 degrees. We put that to use in this next one here. If an angle Y measures 35 degrees, find angle X. Okay, so let's go ahead and measure this one, or label it rather, 35 degrees. This one has the box. We know this one to be 90. Okay, so we know what's there. We do not know what X is. We can find it. Alright, we'll go ahead and add what we know. So 90 plus 35, that's going to give us 125 degrees. Okay, we know all three of these added together would be 180, so I'm going to go 180 minus 125, find out what I don't know, and that's going to be 55 degrees. So X is equal to 55 degrees. Okay. Not only do we have to do that in this one, we also have to classify it. Okay, it says identify each triangle as isosceles, equilateral, and scalene. Okay, those are all classifications according to the side lengths of a triangle. And then right, acute, and obtuse refers to the angles inside of a triangle. Okay, so let's go ahead and find the missing angle first. Alright, we know all three of these will add up to 180. So let's add together what's there. We're going to go 90 and 35, or excuse me, 39. We'll add those together and we'll get 9 here and 129. So we know what is there, and now we have to take it away from 180. So 180 minus 129. So the angle we don't know here is 51 degrees. You can always check yourself by adding them back together. It always should add up to 180. Now let's classify it real quick. Isosceles means there are two side lengths that are the same. Equilateral means all side measurements of a triangle are the same. And a scalene means none of them are the same. Okay? Now if we take a look at this one, the angle measurements actually tell you the answer here, okay, because different opposite angle measurements mean different side lengths, okay, so all the angle measurements are different, so that means all the side lengths are going to be different. So in this one is a scalene. And to the classification referring to the angles here, what do you see in that triangle down there? If you see a right angle, then it automatically is a right triangle. So this one is actually a right scalene triangle. Okay? Done and moving on. Okay, so for number 2 here, first let's find the missing angle, then we'll have to classify it. Alright, we have two 72-degree angles. We need to know A, so I'm going to add together what I know. 72 and 72 should get me 144. I'll turn around and go 180 minus 144 to get 36 degrees. Okay? Now, to classify it, let's take a look at these again. Isosceles means there's two sides that are the same. Equilateral, all sides are the same. And scalene, no sides are the same. I see two angles here that are the same, so that means their opposite sides are going to be the same. And so this one is an isosceles. Had to look how to spell it here. I think I did that right. And then I'm going to classify it according to the angles that we see. Now, all angles inside this triangle are less than 90 degrees, so this one is an acute isosceles triangle. Okay? All angles have to be acute to classify it as an acute angle. Okay, on our last example dealing with this particular type of problem here, we have, I see 118 right away on this angle and 32, so I'm going to go ahead and add those together. Okay, so what I know inside of there is 150. Alright, and so then I'm going to turn around and subtract that from 180, and whoop, and anyway, I should get 30 degrees. So the measure of x is 30 degrees. Now I have to classify it. Alright, here we go. Here we're thinking again, isosceles, equilateral, or scalene. All sides are going to be different because all angle measurements are different. So this one's scalene. And then what do you see for angles? Only one obtuse angle can be present in a triangle. So this one would be an obtuse scalene triangle. Okay, complementary, supplementary angles. Two angles are complementary if the sum, so we add those together, of their measures is exactly 90 degrees. And notice it says exactly. It can't be 89, it can't be 91. If we were to put together 65 and 25, we would get 90. We can automatically tell that these two angles will add up to 90 by this box here. We have two acute angles that make up complementary angles. All right? Two angles are supplementary if the sum of their measures is exactly 180. So here again, it can't be 179, it can't be 181. Okay, these two angles as we look at 45 and 135. And so basically this space right here and then this space right here, okay, will form this half circle, which is 180 degrees. All right. Trick of the trade on this one, look for the straight angle. Okay, notice that these two angles, they both sit on a straight angle. Telltale sign there to know that they're supplementary. Okay, let's use this knowledge a little bit. Tell whether the angles are complementary, supplementary, or neither. So basically, we just have to add these together. Let's go ahead and add them together as they sit here. This is going to give me a 0. I'll carry the 1 and we'll have a 90 degrees. If I remember right, exactly 90 means complementary. Okay, on to number 2. We'll go ahead and add these together here. 146 and 44. And for this one, I'm going to get 190. I don't recall supplementary angles adding up to 190. That was 180 rather, so this one's going to be a neither. Okay, good example of how they try to trick you on that. Find each missing angle measure. Now we've done this. Okay, kind of like in triangles here, we need to first know what they will add up together. I know that 62 and x will add up to 90. I see this little box right here. Okay? And so all I have to do here is go 90 minus what I know. 90 minus 62. So x is going to equal 28 degrees. Okay? When I go over to this second example here, I see the straight angle. Okay, that gives it away. That means this whole thing is 180 degrees. So all I have to do on this one is 180 degrees minus what I know. Well, I see a 24 here. This space right here is what I know. That's 24 degrees. I subtract that out. I should get 156 degrees. So x equals, angle x equals 156. Okay, so I just took 180 minus 24 to find the missing angle. Okay? Alright, so remember, complementary angles are made up of acute angles. Alright, last little topic here. We'll talk about angles and intersecting lines. Okay, as we see a set of parallel angles here, two lines that'll go on and never touch, always stay the same distance apart from each other. When two lines intersect at one point, the angles that are opposite of each other are called vertical angles. Okay, vertical angles have the same measurements. Okay, so two basic things you need to remember here. The fact that B and B are opposite of each other. Okay, that means this angle and this angle are going to be congruent. They're going to be the same. It's going to be the same measurement. Okay, likewise with the A's. These two angles are vertical. They're opposite of each other. Okay, they're going to be the same measurement and, or in other words, congruent. Okay. Let's apply that to what we know here. Angle 1 has a measurement of 110. Let's go ahead and put that up there. Find the measurements of angles 2, 3, and 4. Well, if angle 1 is 110, I know angle 3 also has to be 110 because they are opposite. See, this is two lines intersecting at a single point, and those are vertical angles. Another set of vertical angles up here is going to be 2 and 4. However, we do not know what their measurements are. How could we find this out? Well, if we look for the straight angle here, remember we can make this semicircle right here. That means angle 1 plus angle 2 should equal 180. So if I take 180 and I subtract away the 110, I'll know that angle 2 is going to be 70 degrees. Alright, if angle 2 is 70 degrees and angles 2 and 4 are vertical angles, that means angle 4 also has a measure of 70 degrees. Okay, so the concept there being the vertical angles. We just have two lines that intersect in one spot. It forms four angles. The opposite angles are going to be congruent. Vertical angles are congruent. They'll have the same measurement. Okay. So now we take a look at this, and it asks us to determine all the unknown angles of this figure. Okay, so let's find them here. First of all, we'll find X. Where is that? That's located right here. Okay? Alright. Now what do we know about triangles? Alright, three angles inside of a triangle add up to 180. That's pretty good knowledge we'll use. The other thing we'll use is supplementary angles. Look for the straight angles, and 180 minus what you're given should give you another angle measurement. Okay. The hardest part here is identifying what triangles to use. We're trying to find X here, and so I want you to see this triangle right here. Okay? And as I look at that, I see I have a 73 and an 83 put together right there. And so now all I have to do is add those two together first. So I have 73 and 83. 156. Now x should equal 180 minus 156. Okay, so x is going to equal 24 degrees. Now, on to m. Where is m? All right, m is right here. Okay, I'm going to go a little different route on this one because what I see right here is a straight angle. You know, a lot of times I like to draw the semicircle right here. And it looks like that on that straight angle I see two angles. Angles m that we don't know, and then angles that measures 68. Okay, what do we know about straight angles? What do we know about half circles? Well, m plus 68 should equal 180. Okay, and so what I'm going to do here is I'm going to go 180 minus 68, the angle I know. And that should give me 112. So there I found m to be 112. Okay, now we need to locate angle y. All right. Angle y sits in a triangle right here. Okay, so the three angles here, it's this one, 64, and z. We don't know z yet. All right, and so we may have to skip over this one just for a minute. All right, and then we're going to look at this little triangle. Okay, let's look at this little triangle right here. I see x, I see angle m, and I see angle z. It's getting a little messy up there, so I'll try to keep this clean. But we know what x is. Remember, this was 24. We also know m. This was 112. We don't know z. That's what we want. So if we added these together, if we went 112 plus 24, looks to me like 136. Now to find z, I can just turn around and go 180 minus 136. That's straight up 44 degrees, excuse me. 44 degrees. Okay, now let me clean this up a little bit and we'll get back to our last one. Okay, so here again we're trying to find y. So let me do this again. We just found z. We know that one to be 44. Okay, so we have 64, 44, and y. So let's go ahead and add these together. 64 and 44 added together is 8, 108. Okay, turn around and go 180 minus 108 should be 72. So that one's going to be 72 degrees. Okay. And so basically to dissect those and find the missing angle measurements, we use two different things. We use the idea of supplementary angles that sit on a straight angle, and we use the fact that three interior angles of a triangle add up to 180 degrees. Okay. This next example is just a little bit different, but the same basic concept. It wants you to find some x, y, and z here. As I look at this first one, I see the straight angle. Here's two angles sitting on a straight angle. Straight angles, we can make this semicircle. And so for this one, all we would do is go 180 minus 60. And that should get us 120 degrees. So x is done already. All right. Now I'm going to go ahead and subtract. I learned from last time. Try to keep everything a little cleaner this time. Alright, let's look at y here. Now, here again, I see a straight angle with two angles coming off of it. Remember, that's the half circle. So we can go 180 minus 145, and that's going to give us 35. So y is going to equal 35. Clean this up again. Okay, so now I have a triangle where I know two angles, and I'm missing the last one. Alright, so I'll add these two together, and I'll get 155, and I'll take that away from 180. And I should get 25 degrees there. Okay? On to figure 2, last example here. Alright, I see a triangle off to the right where I know two of the angle measurements. So right away I can add those two together, 47 and 53, and that should get me 100. All the interior angles of a triangle add up to 180. So 180 minus 100, and that should mean that x is equal to 80 degrees. Now, if you look at this, it should give us a hint to the next one. Alright? I see two lines here intersecting at one point, forming some vertical angles, forming some opposite angles. Alright? If this is 80 on this side, so that means this is 80 on this inside of that one. Alright. And so now we're really just trying to find what y's are. So that when they put the y's on both angles, that means these two angle measurements are exact same. They are congruent. Okay? And so all of these added together are 180. So let's take away what we already know. 180 minus the 80 that we just found will give us 100. Alright, so that means y plus y equals 100, and they are the same, so those have to be 50 degrees. Okay, I forgot to put the 100 up here. Or no, x was 80, excuse me. Getting lost. Okay. Alright, went through a lot this week. It all stems from this stuff right here, though. If you can classify and know why we classify angles this way. Don't forget about the vertical angles we talked about over here. That may or may not have been new for you guys. Vertical angles are formed when two lines meet at one spot. We have those opposite angles. They are congruent. Okay, good luck on the Kahoot. We'll see you guys next time.